Hello everyone. So we're going to get started here, and in order to do that, I'd like to start off with with this particular statement here. So you may recall last time we talked about constructing truth tables for specific statements. The same is going to happen here. So I'd like you to go ahead and take a look at this here. I suggest that you pause the video for a bit and go ahead and construct this before we go over it. Alrighty. So note that in this situation here, we're going to go ahead and create our truth table as such. We're going to have P and Q here because these are our base statements, and as always, we want to set it up the proper way here. True, 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 false, false, true, false, false here. And now we note that, again, we're going to look at the components of this. We see that the parentheses give us a natural way of grouping the statements together. So we know we're going to have P implies Q as a column here. We're also going to have Q implies P as a column here. And then finally, we're just going to simply glue the two statements together. P implies Q and Q implies P here. So we can go ahead and put that together here. So if you recall, P implies Q, if you recall from previously, we know that a conditional is false only when you have a true antecedent leading to a false consequent here. So that means row 2 is going to be false, whereas the rest is true. Now again, we can follow the same idea here for Q implies P. Now note that in this situation, Q is the antecedent and P is consequent here. So we have to be kind of careful about that. So in this situation, in this case, the only way we have a true leading to a false is what happens in the third row here. Q is true, P is false. That's going to be false here, and everything else is going to be true. And now the final column here, you can see this final column in this situation. This final column here, it's a conjunction, and of course a conjunction is only true when both components are true. And that only occurs in row 1 and row 4, and everything else is false. So if you take a look at this here, we've learned that this statement here is true, false, false, true. So it's a little bit different from what we've looked at so far, right? Everything we've looked at so far, it's been divided 3-1. But here it's a little bit weird, right? Now it's true, false, false, true. So what exactly is this statement telling us? Well, let's go back to yesterday. Our previous lesson told us that we had something along the lines of, we had a conditional was, if you take this medication, then you will stop sneezing. But notice how here, basically, if we do the same sort of substitution, we have, if you take this medication, then you'll stop sneezing, and if you take this medication, then you'll stop sneezing. So note that here, something that we mentioned in the previous lesson is that there was another way to stop sneezing other than just taking this medication. Now, by gluing this here, we seem to add this new caveat, this new condition, that the only way to stop sneezing is taking this medication. There is no alternative treatment here. So not only if you took this medication, then you stop sneezing, but it also worked the other way. If you stop sneezing, then you had to have taken the medication here. So in a way, it's saying that P and Q are irrevocably linked to one another here. And this is important enough that we give it its own name. So in fact, in this case, we refer to this as what is known as the biconditional here. So the biconditional here is our statement. In this situation, our keywords will be if and only if. So we read this as P if and only if Q. Note that the symbol here for the if and only if is just a double-headed arrow. So it shows the conditional working in both directions. So P if and only if Q here. So we can read this as P if and only if Q. Now note that in this situation here, again, we mathematicians don't like writing words out very much here. So instead of writing the phrase if and only if, we can say P-I-F-F-Q. So IFF is just a shorthand way for us to write the phrase if and only if. So basically, going back to what we have here, we have this, if you take this medication, then you will stop sneezing. And if you take this medication, if you stop sneezing, then you take the medication, or you took the medication here, we can compress that and condense that into you will stop sneezing, or if you will stop sneezing if and only if you take this medication. Alternatively, you can say that you took this medication if and only if you stop sneezing here. So again, it shows a sort of a comparison here. It shows an equivalence. So note essentially what's going on here is, what's going on in this situation is that, do you match? If yes, then true. If no, then false. So note that here in this situation where the biconditional, this is a matching here. It shows that this situation is only going to be true when either both are true or both are false. And it shows an equivalence here.